Organizations today are facing unprecedented challenges. Increasing pressure on operational efficiency, clinical results, patient expectations, and financial performance have created an environment where staffing shortages are causing providers to look at new ways to conduct the business of healthcare. Hello, my name is Ken Puffer, the Healthcare CTO for ePlus Technology. Joining us today, we have Juan Martinez, one of John Snow Lab's senior data scientists. In this presentation, we will be discussing real-world AI projects that use John Snow Lab's platform to improve operations, clinical outcomes, and safety, the hardware platform provided by ePlus, and benchmarking results for Spark NLP. Then we'll move to Juan, who will provide a live demonstration and show us how the platform works. As you can see, ePlus is a technology solution provider publicly traded on NASDAQ for over 30 years. We provide technology solutions for over 2,000 OEM providers to our over 3,500 global customers in all verticals. In 2015, we created our healthcare practice to provide a focus on the needs and technology solutions to over 350 healthcare organizations today. One of the more recent additions to our solution offerings is an artificial intelligence platform where our customers can more easily develop and run their own algorithms and applications to improve business and clinical outcomes. Presenting this platform today is Juan Martinez. Hello, Juan.
Thank you, Ken.
You're welcome.
Hi, hello. Thank you so much for the introduction. John Snow Labs is the company behind the Spark NLP, and we have been around since 2015. Since then, we have built a unique open source library on top of Spark, which means it's the only library that is by nature scalable and production ready. And also the only one that is focused on bringing state-of-the-art NLP models to the healthcare ecosystem. During these years, we have helped different stakeholders in hospitals, pharma companies, insurance, laboratories, and public institutions to solve different use cases, as the ones I'm going to describe a couple of slides later. So right now, our library counts on more than 600 models, including name entity recognition, relation extraction, the identification of protected health information, clinical entity linking, to taxonomies as SNOMED, ICD-10, RxNorm, LOINC, etc., detection of negation, past, present, future, in text, what we call assertion status, and many others. And all of these healthcare models are trained in-house with the state-of-the-art deep learning architectures, including transformers, using both public official data sets and in-house annotations done by our team of medical annotators. Also, we actively publish and take part in competitions to guarantee that our models keep providing the best performance. The publications and results are public, so feel free to reach out to us if you want to take a look at them. So now, about the problem statement. Yeah, so after this introduction, let's take a look at the problem statement itself. So back in 2015, in the Neural Information Processing System Conference, Google published a paper about the situation with machine learning environments. So this figure was extracted from that paper and shows in this very little black square in the center that only the smallest fraction in ML solutions is actually the code. The rest is infrastructure provisioning, monitoring, configuration, management, analysis, all the rest. So the situation has slightly changed from that time on, but unfortunately not that much. What we are going to present today is how ePlus and John Snow Labs can help you provide your technical teams with a joint platform for data processing, visualization, modeling, experiment tracking, infrastructure, group management, etc., on plus of the ePlus infrastructure. Yeah, but first, let's discuss some client success cases taken specifically from US hospitals. So first of them is Kaiser Permanente, who developed a real-time decision-making system to properly optimize and plan the bed demand levels and the nurse staffing requirements, depending on the patient workflow. The main questions to answer here were how likely are that the incoming patients are going to be admitted, for how long, for what reason, what is going to happen next, right? So to accomplish that, Kaiser Permanente collects several features from unstructured nodes, including the acuity level of the patient, the ongoing treatment, level of pain, intensity, etc. With the unstructured data extracted by Spark NLP in form of features and annotations from a domain expert, we can train decision-making models to get the proper predictions for future incoming patients. For Mount Sinai, we want to illustrate today 2 use cases. First of them, a predictive model to detect potentially aggressive patients in psychiatry. Mount Sinai trained a model with in-house annotations on progress and care and social care worker nodes that are unstructured clinical nodes using the Brosset score, that is a risk assessment metric, to predict imminent violent behavior going from 0 to 2 or beyond that scale. So again, with annotated data and entities extracted from unstructured data, you can achieve this type of regression or classification models that help physicians in the decision making. Also, for Mount Sinai, we wanted to highlight that they trained the predictive model on a very high volume of clinical nodes, pathology and radiology reports, for which they require an NLP solution that really supports big data processing, as Spark NLP does. As I mentioned before, by running on top of a Spark, that is a cluster-ready infrastructure, you can scale your processing from little documents or proofs of concept to production-ready use cases with big amounts of documents. And the last use case that I wanted to mention today, which also has to do with processing big volumes of data at scale, is the one for Providence PHI de-identification. So in Providence, they wanted to use Spark NLP to de-identify several 100,000 of clinical nodes at scale. Using the Spark NLP on a cluster infrastructure that is native to Spark NLP, they were able to identify up to 500,000 nodes in a bit more than 2 hours.
Thanks, Juan. So just a little bit about the infrastructure platform that ePlus provides. So working with John Snow Labs, ePlus has put together 2 workflow accelerator bundles to meet budgetary and performance needs of just about every customer. Starting with our entry-level platform, which runs on an NVIDIA DGX station, it's configured to support individual scientists up to a small team. For larger teams of 5 or more, we've created an advanced offering that is configured to provide effective performance-driven results for those teams. We include installation services for the software and hardware to get your team started and offer special training packages to further accelerate your team's learning curve. So from here, we're going to jump into the AI platform.
Right, so yeah, let's talk about the platform itself. So AIP stands for Artificial Intelligence Platform, which is one of our products in John Snow Labs. With this platform, you can write your own software using your own data. Although Spark NLP and the AI platform itself can work in cloud environments as well, we offer the only solution that can run state-of-the-art NLP models in healthcare, with all the processing being done on premises with no internet connection required, without sharing or sending data, without having your data leaving your own servers. Although you don't share your data, you can take advantage of any of the 600 healthcare models that I mentioned before, and more than 5,500 open source models that we have available in our Models Hub. The AI platform is the perfect meeting point for data scientists who want to experiment and code using Python, R, or Scala, for analysts and domain experts who can use visualizations and dashboards in our Visualize UA to answer domain questions, and finally for system administrators who can monitor and ensure access, resources being consumed, activity, etc. In the next slide, we can, we will take a look at a 360 overview on the different capabilities that I will be showing later on in the live demo, including notebooks executing Spark NLP libraries for name entity recognition and relation extraction. For example, you can use as well our visualization tools in different stages of the experiment. For example, as a first stage to explore the data before planning the approach to your problem, during the process to show to domain experts the results that you are getting, or at the end of the project to illustrate the conclusions that you got. From the monitoring perspective, you can adapt the consumption of resources to your own needs, granting specific permissions to a group of people, managing log using signing providers, checking access logs, security audits, etc. About this very first part, that is the explore part, as I was mentioning before, we provide 3 languages for which we have notebook support, that is R, Python, and Scala. And something that I did not mention before is the support for experiment tracking, metric storage, versioning of the models, and even serving the models that you have already trained using MLflow. So MLflow is also natively integrated with our platform. This is the part of exploring or coding programming. Let's take a look at the next slide that is about visualizing the resource that you are getting. So this visualization module allows you to upload the data in different structured formats, including CSV or JSON, execute SQL queries to retrieve partial distributions of your data, visualizing the results with different pre-trained views, creating dashboards as the one that you see in the image, etc. For unstructured data, you can use Spark NLP annotators as entity name recognition or relation extraction, assertion status, etc., or even keyword extraction, so that you transform those clinical notes on unstructured data into structured information and then visualize them in the visualization module that we were showing before. For this very third module, that is the operate one, this module allows any sysop or system administrator to administer roles, groups, identity providers, monitor CPU usage, memory access logs, etc. Cloud administrators can manage the AI platform as well with features like the Kubernetes cluster management, including nodes, pods, volume, storage management for scalability, resource optimization as well. So before jumping in to the live demo, we wanted to share with you some of the experiments that we carried out with a Spark NLP library on top of the ePlus infrastructure. So these are some metrics about how to leverage high-performance infrastructure, such as the one with NVIDIA Tesla V100 GPUs, which ePlus provided us to run these benchmarks. As you may know, most of the natural language processing state-of-the-art tasks require big computations due to the use of neural networks and transformers architecture. This is the sweet spot where connecting Spark NLP to GPU machines can really make a difference. Spark NLP uses TensorFlow natively to solve different tasks at scale with very high performance. So, for example, in the very first table that we see on the top, for roughly 500,000 documents of clinical notes, we got a 86% of improvement when calculating the embeddings for our clinical notes compared to just using good CPU machines as the one that we use for comparison, that is an AWS M5 8X large, consisting of 32 cores and 128 gigabytes of RAM. So for those who don't know what embeddings are multidimensional numeric representations of text, which are used at the very first component to process any other NLP task, as I was mentioning before, in name entity recognition or relation extraction. So the main takeaway here is that the bigger the documents they are, the more performance you get. So this is the power that lies on using GPUs on transformers and big documents. So in the second table that you see on the bottom, we illustrate another scenario that is splitting a document into sentences, into smaller chunks, and both training and inferring a sentence classifier. That is getting sentences and assigning them a class from a subset of classes that we may have in our use case. We include here the training and the testing times, but both of them resulted in a 76% of improvement compared to the same AWS machine that we were referring to before. So this improvement is a little bit smaller than the one in the first table, because as I mentioned before, the bigger the documents are, the more improvement we get. So in this second scenario, in the second table, we were using a sentence detector that is basically a sentence splitter that split the documents into smaller chunks. And although this provides also with a huge improvement, we can see that it's slightly smaller than the improvement that we got in the first experiment.
Thanks, Juan. Now we'll just move over to the AI platform demo here. So while I do that, let's switch screens, and then Juan will run the show us the platform itself and guide us through the demonstration. So just let me know when you're ready, Juan.
Okay.
I'm hoping that
All right.
that our teams here, that everybody here is able to see and really begin participating. Just to let you all know that there's a place to, you can use the chat button to post any questions that you have, and we'll be taking and responding to some of those questions here in a couple of minutes. We already have a few. So thanks, Juan. Sorry about that.
Thank you. Can you use my screen now?
Yes, I can.
All right, so these are the three modules that I was explaining before, our experiment modules for programmers, for data scientists who want to run, to program, to use our Spark NLP library for creating experiments on their data or proofs of concepts or even to scale to production solutions. In this very first module, what we can see is the notebook lab, where we can actually program and use the library using the notebooks I'm going to show you a little bit later. Then we also have this second module or sub-module that is the ML flow, that is for experiment tracking or model serving. That is basically when you are happy with the model that you have trained using Spark NLP library, you can just save it, store it, and consume it later on. Or even if you want to keep track of your experiments to check if another hypothesis gave a better result, you can use MLflow interface to compare the metrics and to choose the best model. Also, I'm going to show later on the annotation lab. There is one of our products that is also free to use, that is meant to be used by annotators to annotate your in-house data and structured data to train models. But also, since it's a zero-code platform, you can use it to train your own models without needing to go to this notebook lab and train the models programmatically using code, right? Not all the features of the Spark NLP library are available in this zero-code fashion, but some of them, as name entity recognition, will be, or relation extraction will be available there. Then the second module is for visualizing the data and doing some SQL dashboard, charts, or dataset management. And the third one is for system administrators or cluster administrators to manage the cluster, the configuration, the signing providers, etc. Let's take a look at the experiment. So the very first one should be this one, this notebook platform. I have already my server started, as you can see, but in here you can start as many servers as you want just by clicking on a button here that could be a start a server. That basically what will start is this interface. This platform already comes with a lot of examples of notebooks that are available at a Spark NLP Workshop GitHub repository. You can find it in here as well. So Jon Snow Lab Spark NLP Workshop repo in GitHub has many examples, and all of them are can be used here in the platform to do your experiments, to check how the library works, so that you don't start from scratch. I would like to show you two of them. One is for clinical name entity recognition. That is the notebook number one, so that you can see how our pre-trained models, so models that are already available of those 600 that I mentioned before for healthcare and 5,500 for the open source and generic domain are available. So how you can use them to extract entities and to visualize your clinical notes with those extracted information. These are just some of them, some of the pre-trained models that we have for entity recognition. As you can see, including different languages, German, Spanish, and different pathological areas. Or, for example, we have for detecting measurements for posologies, drugs, phenotypes, oncology, radiology, biological models as well. So yeah, this is just an image, but let's see it in action. So this is what we call a pipeline. There is basically a set of components put together. So the output of one goes to the next one, and that one enriches the information with more functionality that it has before. So as a document gets in, or a series of documents get in, they get enriched by all of these components or annotators, and the result is an annotated set of documents or data set. So yeah, for example, we can have a set of clinical notes, and by processing them with this pipeline, you will get the documents from them, split them into sentences, then into words, use this embeddings I was mentioning before, that is this multidimensional representation of the text. And then we have this annotator that is medical NER for doing entity recognition. Let's take a look at the output, because you can see the different classes or entities that we detect. In this example, we're taking a look at treatments and problems and tests. This is more low level for data scientists, but what I want you to show is how you can get the text, and this is the actual data frame, but by extracting the last column, that is the NER or the NER chunks, you get things like that with the words and the entity that was assigned to those tokens or to those words. You can see the distribution, but also the most important part is that you can visualize. You have our Spark NLP display library, so that instead of taking a look at the text results, you can highlight them in a text and figure out if they make sense or you need to do something else. All of these notebooks include also training capabilities that you can see on the bottom of the notebooks. So you can even, if the results that you are seeing are not 100% perfect for your use case, you are able to fine tune, to retrain the models with your own data, so that they get adapted to your specific use case. And another notebook I wanted to show you is the clinical relation extraction. There is a step further from name entity recognition, that is, and what it does is, after extracting entities, you detect if there is any relation, or if they have something to do with each other, right? Let's have an example. These are some kind of relations. So, for example, the relation between a drug and its duration, or the frequency, or the strength. Let's take a look at some of them. It also has its own display module. So in this case, we are detecting first entities, as in the previous notebook, with dosages, drugs, and durations, but also we are showing which relationships these drugs have with the durations or dosages. Because if we do name entity recognition, we get the entities separately. But in most cases, what we want to have is them connected to each other, right? So in this case, the patient was prescribed 1 unit of Advil for 5 days. We see that the drug is Advil. And connected to Advil, we have a dosage drug relation that points to 1 unit, and also a drug duration that points to 5 days. Feel free to experiment with and check these notebooks that are available also in our GitHub and included in the AIP platform as well. Just to mention, we include not only NLP models, but also OCR, in case that you have image documents that may be, for example, DICOM. We also process and manage DICOM images, for example, just in case you want to extract some entities to de-identify for protecting patient health information. Okay, let's go back to the second module, that is the visualization module. If you click in SQL Analytics, you go here where you have different dashboards, charts, and SQL Lab. Here you can visualize your data. One of the screenshots that we had in the presentation was this one. That is a relation dashboard that I created. So basically, I had this relation notebook that I have just presented, but with another models that were trained with the I2V2 dataset or challenge that basically had the entities on one hand that are treatments, problems, and tests. On the other hand, relations between them. For example, if a treatment improves a medical problem, then between those entities, we have a TR-IP relation, right? So this is something that you can use after you have finished or you have your models extracting the entities from using Spark NLP. You can get those entities and those relations in an structure format, in a table, in a CSV, and present them with this kind of dashboards. This is the way to go from unstructured data to structured data. So you can be able already to query, to do SQL, to present these results to domain expert physicians, etc. One of the charts that I wanted to show you as well is how to do explorations in more like in a journey way, so that you can travel from one point to another. This may seem overwhelming, but this is just consuming the results of our Spark NLP models or of our relations and entities. Let's take, for example, this relation that is PIP. We can disable all of the rest, and here we have all the entities that are the dots and the connections from one to another, so how these relations connect the dots or connect the nodes. If we go back to the visualization, 1 second, I wanted to go over to the dashboard. Yeah, here you are, to what the PIP relation means. So in our data set, in our model, PIP means that a medical problem indicates another medical problems. So what we are going to see here is how one medical problem is pointed to another. This is basically this visualization right now I'm showing right now. Right, so for example, this one, or so you can select, you can hover, and to see all of the connected information. And for that, you can do the same for all of the relationships. The bigger the node is, the entity is, the bigger the example you have. So you can also take a look at that. Very important, you can you have also this SQL interface where you can just explore your data set in a raw format, in a CSV. So this is the output of Spark NLP, the output of a data set with all of the entities and the relations between them. So you can see what I was mentioning before, PIP, etc. You can take a look also at the raw data here. You can have different, you run the different queries, so have the different data, all the relations. So everything that you may want to explore here in this SQL Lab. And yeah, and you can upload any kind of structure format, a CSV, columnar files, databases, datasets, etc. And the last but not least, let's come back to the third module, that is the operate module. In this operate module, that is more for, as I was saying before, more for system administrators, you can check and to manage the Kubernetes cluster. That is basically saying this is the infrastructure that is behind this platform, with for checking the CPU usage, the memory usage, or how many nodes are in this cluster that is running right now, on what are the disks that you are having, what is the storage of them. So purely infrastructure monitoring. But also we have identity and access manager in case you want to connect and to allow users to connect to this platform using identity providers from social networks or other sign-in providers at GitHub, Facebook. You can configure everything from here. You can have roles to properly configure the access to the platform. And also, the last part I want to show you is how you can monitor the logs. So we register every activity that is happening in the platform. So if you go here, you can have such complex dashboards of access. For example, how are you consuming this using API, right? Because we have API access. So in here you have all of the activity. Yeah, so very complex dashboards based on the logs that we are storing for all the different modules of the platform. So that was it on my end. So yeah, feel free to ask questions if you have any, and I will be very, very happy to answer them.
Thank you, Juan. I really appreciate it. This is a great job. So want to move on to, take a few questions. We have a couple of posted questions that I think you may have answered already, but want to give you another, another chance, to expand on it if you want. The first question is, does my data have to be in any particular format to get started?
Yeah, that's a very good question, and usually is frequently asked. So Spark NLP is an extension of Spark, and Spark works with almost all kind of formats. You can work with unstructured formats directly importing TXT files. You can work with CSV files that has, for example, some structured data, but also they have a column with the text that is unstructured, so this kind of hybrid formats, JSON as well. So this is the good thing of being a natural extension to Spark NLP to Spark, sorry, that task has already been managed by natively by Spark, and you don't need to worry about that.
So I also, I noticed that obviously, you are connecting to SQL databases, and I think there was other options there to connect to, online data. And one of the more interesting things that I saw was, being able to take this outside of just, I'm going to say simple structured to, into some unstructured areas. So that was very interesting to me, as well as some of the DICOM data that comes along with with modality images.
Right. Yeah. So I think that one of the main tasks of NLP is structuring the unstructured data, because otherwise unstructured data you cannot exploit, you cannot query, you cannot get insights from it. So that conversion from unstructured data into structured data is possible thanks to NLP techniques, and in this case with the Spark NLP, you can do that at scale for many different kind of documents, for many different kind of NLP tasks. And then once you have that structured data, feel free to visualize, to connect all of this information together, to exploit, to answer questions. So that's the magic of NLP.
Yeah, excellent. The next question we have, and again, you kind of touched on it a little bit, is how does AI Lab, the John Snow Lab platform, address security and compliance?
Yeah, so this very third module that I was referring to before, so this operate module allows you to manage so who logs in, what are those people doing. So we have this sign-in provider configuration. We have roles to allow users doing something or not allow them. We have as well, monitoring and logging of what the different users are doing, just in case we want to have some audit of who's accessing what, right? So this is very very specific, specifically done for all the modules and all the different functions and tasks that you can carry out in the platform. And also the best part of it is that everything that you have seen can be run on premises. So you can just cut off internet and get this working in on premises, in your own servers with your own data without having to worry about any potential attack from the outside.
Yeah, I really, I was thinking about that last part a lot, and there's definitely a place for for having that data available, from a cloud-based platform, but the security controls that you have to put around that may not be um, as familiar to your security administrators and security operations teams as the tools that they're currently running for to protect the data that's on site. So yeah, it definitely is more common and in some ways more beneficial for organizations to run and maintain ownership of that data within their own systems on premise. So yeah, that was interesting, to me, and to be able to, as a former CISO, to be able to really see that from a compliance, and control standpoint. Now, the last question that we have so far is, how would my team get started with Jon Snow Labs?
So we provide trial accesses. So if you are interested, if you visit johnsnowlab.com, you can apply for a trial license and start working. So most of the modules that I have showed today can just be run with that trial license. And in case that you're interested to continue working with us and you have some use cases you are interested in and you decide to go on, then we have a different kind of licenses depending on your infrastructure. If you are going to use clusters infrastructure because you have big data, or you are going to use only single nodes. So this is a discussion that we can also have. And yeah, so most of the modules that we included in the AI platform, for example, are free to use. So they only depend on the license that you have. If you have a license for, so we have two different kind of products that are commercial, that are the Spark NLP for Healthcare library and the OCR. But we also have a lot of models that are open source, these 5500 that I was mentioning before. So our modules work, we offer them for free, and they work for free with the open source models. But if you get a license for example, the Spark NLP for Healthcare library, then all of these modules and the AI platform will get that license. So it's just a question of clicking someplace, uploading your license, and then all of these 600 plus models that we have will be automatically available in the AI platform, so that you can use it in the notebooks, in the annotation lab application, etc. And the other one is the Spark OCR, that is an independent commercial product, but it works the same. If you are interested, or you have non-textual documents, images, or scanned documents, again, you can have a trial license, take a look at how it works. If you decide to move on, then again, you have this OCR license you can include in the AI platform and work with the Spark OCR library that is at the same time connected, natively integrated with the Spark NLP for Healthcare and the open source part. You can put components of all of these three libraries in one, combining the libraries for which you have the license, and work seamlessly with all of the modules that I have shown to you before.
Great, thank you very much, Juan. I was, as you was talking about the OCR capabilities and those workflows that that involve scanned documents and turning those scanned documents, which are images, into I'm going to say functional, useful data points. Very, very important, and still in a lot of use in a lot of healthcare organizations. So John Snow Labs and ePlus have been part of helping organizations realize the clinical, financial, and efficiency benefits of automation, machine learning, and now artificial intelligence for quite some time. I've really never seen more opportune time to embrace these technologies than today. So thank you for your time and attention. If you would like to discuss how our AI Workflow Accelerator can benefit your organization, please reach out to us using the email address you see here, healthcare@eplus.com, or visit our webpage at eplus.com/healthcare to request a demo and contact information. Thank you very much for your time today.
Thank you.